In this example, we're using the equation of lines in space and vectors to help us understand the path of a ship. Okay, so we've got a ship that is leaving here from port A and is traveling in this particular direction. They tell us it's traveling in the direction 3, 4, and it's at point A at time 0. And then at one point they're going to ask us about a second port P over here. So that's another part of the problem. So as we get started here, they tell us in the direction at the speed. Okay, well, so if you have the direction vector 3, 4, we know that the magnitude, let's just call that vector D for direction vector, the magnitude of that vector D is going to be equal to 5. You may notice this is a 3, 4, 5 triangle. But they told us that the speed is 10 kilometers per hour. So this direction, if we just used the vector 3, 4, we would have only gone 5 kilometers. So when we write the equation of this first of the line, we want to actually double the magnitude of that direction vector. So we would say, okay, well, our equation of a line xy would equal, well, where did we begin? We began at negative 8, 3. We began at the point negative 8, 3, and so we needed a vector that got us from the origin to point A over here. So that vector, it's the coordinate negative 8, 3, but the direction vector, it's the direction negative 8, 3 going that way. I said direction, that's a lie, I mean position. The position vector to get from the origin to point A is negative 8, 3. And so then now we have plus t times, and we're, instead of using the direction vector that they gave us, we're going to double it so that our time can really mean 1 hour. So that every hour we go 10 kilometers, so this becomes 6, 8. So now, so here's the first equation. So we have the equation xy is equal to negative 8, 3 plus t times 6, 8. And we want to talk a little bit about what it means now to be a point on this line. Or where will the ship be? So at time, say 2 hours after you leave, the ship, the vector to get from the origin to wherever the ship is at 2 hours after it leaves, I would expect it to be, but I mean, there's no scale here, so it doesn't really matter where I'm going. I would plug in 2 into that equation, and I have negative 8 plus 12. Negative 8 plus 12 is a positive 4, and then 3 plus 16 is 19. So I would be at the point 4, 19 somewhere. If this is 10, then I'd be somewhere over here. So I'm moving along. I can find any point, and that would give me the point. Whatever that point P is, point P would be the point 4, 19. And that's where you are at time 2 hours after you leave. So any random point on the line, if I wanted to be any, I could think of this as, in terms of, well, if we use a parametric equation, x is equal to negative 8 plus 6t, and y is equal to 3 plus 8t. So any point, any coordinate on this line would have an x-coordinate of negative 8 plus 6t, and it would have a y-coordinate of 3 plus 8t. So we can rewrite this up here, this point R, is in fact the point negative 8 plus 6t, comma, I'm sorry, I didn't save myself enough room, 3 plus 8t. Okay, so we're going to use that to start to look at answer part B. Now they're asking us to find when is our ship closest to port P. Well, the shortest distance from some point on the line to some point P would be when that segment RP is perpendicular. Okay, so when we've got our line and then we've got the time, we want to know when is this here, if this is point P over here, we want to know what point do I use for R such that I get a right angle right in here. So we have vector, we know that the direction vector of this is just, it's going in the direction 3, 4. And we need to find the vector. We can either use RP or PR. It's just a matter of where you want the negatives. It'll work the same way because when I take that vector 3, 4 and I dot it with the vector, maybe let me change my notation, I'm sorry. When I dot it with the vector, well, we'll say PR, then this needs to equal 0 if it's really going to be perpendicular. Okay, so what we need to do here is we need to find the vector from P to R. So I went R, these R values, minus the P values, and have negative 8 plus 6t minus 10. 3 plus 8t equals minus 2 from the y coordinates here. I went ahead and then found the dot product, set the dot product of them equal to 0. When I expanded it out, I ended up here, which looked scary at first, and then it cleaned up to being 50t minus 50 equals 0. Therefore, t has to be 1. So what that's telling us is that at time 1, so 1 hour after the ship left, it is closest to point P that it'll ever be.